My dear students, welcome to School of Fundamental Sciences. Here I will discuss application of differentiation. Truly speaking, it controls innumerable fields in sciences and other sectors. So it is very important. See two sample problems to understand its application, the application of differentiation for practical problems. You see sample problem 01. A particle moves along a straight line with the velocity. Yes, given as a function of t, it is given v is equal to 2 meter per second 1 minus e to the power minus 3 per second t. Now we have to find the acceleration as a function of v and hence the terminal velocity of the particle. Now the particle will have terminal, actually when the particle goes on, in this situation we can have terminal velocity when the particle is moving with a decreasing acceleration. So its velocity gradually goes on increasing, acceleration gradually goes on decreasing. So ultimately time will come when the acceleration becoming 0 and the velocity becomes maximum. And since acceleration is a function of v and since velocity becomes maximum and remains constant, so acceleration will be permanently 0 and the velocity, maximum velocity remain unaltered, and this is the terminal velocity. So when the particle will have the terminal velocity, acceleration must be 0. That means dv dt equals to 0. Now let us find dv dt by differentiation. So v equals to this, it is given, equation number 1. dv dt is equal to ddt of v, then ddt of, yes, set the v value here. Then first it is a 2 meter per second out. It is the commutative law. ddt of 1 minus e to the power minus 3 per second t equals to 2 meter per second. Again it is a distributive law. ddt of 1 minus ddt of e to the power minus 3 per second t. This ddt of 1 constant 0 minus, again you see there is a standard result, ddt of e to the power dz of e to the power z is equal to e to the power z. So you consider minus 3 per second t as z, then change the ddt operation, d dz dt. So d dz e to the power z is equal to e to the power z. That's why I have written e to the power minus 3 per second t into ddt of z. That is minus 3 per second t equals to 2 yes, minus 2 meter per second e to the power minus 3 this, and then again commutative law, minus 3 per second is taken out, ddt of t 1. So we will have minus 3 per second minus 2 meter per second giving 6 meter per second square e to the power minus 3 per second t equals to 6 meter per second square, and this e to the power, because it is what is required, acceleration as a function of v. So e to the power minus 3 per second t, you see equation number 1 is replaced by this one, because e to the power minus 3 per second t is equal to 1 minus v by 2 meter per second. You see equation number 1. Yes. So it is the what? Acceleration as a function of v. So what is required acceleration? A is equal to dv dt is equal to this one. It is the answer. Now already explained, you see, if you see the acceleration equation, then you see when velocity gradually increases, acceleration decreases. Similarly, you see the velocity equation. When time increases, velocity increases. So clearly the velocity becomes maximum when the acceleration becoming 0. That is when dv dt is equal to 0. So you see v becomes maximum, that is terminal, when dv dt equals to 0. So we therefore have 6 meter per second square 1 minus v by this equals to 0 when this v is equal to vt. Vt is the terminal velocity. So 1 minus vt by 2 meter per second equals to 0. So we have vt equals to 2 meter per second. Sample problem 02. The engine of a moving motorboat is cut off when its velocity is v0, and after that the motorboat moves straight with the retardation which is a function of velocity v. Now the distance with which the motorboat is moving, the distance traveled by the motorboat in time t after the engine is cut off is given by the law x equals to 1 by k ln v naught kt plus 1, where k is a positive constant. We have to find retardation of the motorboat. But you see retardation cannot be obtained. First we will find acceleration. Clearly for retarding motion, acceleration becoming negative. So let us first find acceleration. X is given. So first we'll find velocity. Velocity is equal to dx dt. So ddt of x. So ddt of x, set the value of x, set the value of x. 1 by k, yes, commutative law constant, so taken out. Ddt of ln v naught kt plus 1. Yes, again z concept. V naught kt plus 1, consider z. So we'll have ln z. So it will be accordingly changed d dz, dz dt. So d dz ln z means 1 by z. So 1 by v naught kt plus 1, ddt of v naught kt plus 1. So this equals to 1 by k, 1 by v naught kt, and v naught kt plus 1, ddt of v naught kt plus 1 equal v naught k. So ultimately k cancel, v naught by v naught kt plus 1 is velocity. Or the acceleration, dv dt, ddt of v, ddt of put the value of v, and then v naught constant taken out, commutative law, ddt of v naught kt plus 1 to the power minus 1. Again standard result, consider this to be z, d dz, dz dt. So d dz, z to the power minus 1 is equal to what? Minus z to the power minus 1, that means minus 2. That is 1 by z square. That is minus 1 by v naught kt plus 1 whole square into ddt of z. So ddt of v0 kt plus 1 is equal to minus v naught by square, v naught kt plus 1 square, and again here you see v naught kt taken out, ddt of t is equal to 1 and plus 0. So ultimately v naught, from here we will have v naught k. So we will have minus k is taken out, v naught square, v naught kt plus 1 square, that means whole square, equals to minus, it is v, you see equation number 1, it is v, so minus k v square. So ultimately acceleration as a function of velocity, which is a is equal to dv dt is equal to minus k v square. So what is retardation? Retardation is a negative acceleration. Retardation is a positive quantity, be careful. So retardation f is equal to minus a is equal to k v square.